Hello, everyone. Welcome to the today's session on process and threads. I'm Dr. Dhanlakshmi, professor in the Department of ECE, SRM Institute of Science and Technology, Kottayam campus. Let's get started and understand one of the most fundamental concepts in operating system, that is process and threads, which form the backbone for multitasking and concurrent computing. What's a process? A process is a program in execution. When you run a program, example, Chrome, VLC, Notepad, the OS creates a process for it automatically. So what all the process includes? A program code. It's nothing but a text section. That is the actual compiled instructions of the program. It is nothing but the actual instructions to execute is there in the program code. Coming to the second, the process we call as PCB, process control block, a data structure maintained by the OS that contains process ID, we call as PID, process state, it could be in ready state, running state, wait state, terminated state, and a program counter, CPU registers, scheduling information, memory management info, open files, and IO status. It's all being taken care by PCB. And the third the component in process is memory segments. A process gets into its own independent memory space, which typically includes text, data, BSS, heap, and stack. Text is nothing but the code that we write. Data, it's initialized global variables, and BSS takes uninitialized globals, and heap which takes care of dynamic memory allocation, and finally coming to the stack, which takes care of functional calls and local variables. So the fourth component is resources. Each process has its own address space, its own stack, own heap, file handling, IO devices as assigned by the OS. In simple words, I could say a process is nothing but a program plus memory plus resources plus process control blocks. So I have given a pictorial form here. Let's take the blue color thing, the entire circle be a process which contains the different components like, we could see threads, file descriptors, channel, mutex, and memory. So as I said earlier, the process is nothing but a program that's being loaded into the memory. So everything inside this boundary belongs to the same process context, which meaning these resources are shared among all the threads of the process. What's a thread? Threads are independent parts of execution but share the process resources. Each thread can execute different parts of the program concurrently. Coming to the file descriptors, so these are references to open the files, sockets, and IO streams. The threads in the same process share the same set of descriptors, meaning any thread can write or read or write to the same open files. Coming to the channel, channels are the communication pathway that could be used by threads to exchange the data very safely. Pipe, message queues, channels, or languages like Go and Rust. Coming to mutex, it's mutual exclusion lock. Mutex is a synchronization primitive that allows only one thread can access the shared resources like memory at a time and preventing the race conditions here. So coming to the last part, the memory. All threads within the same process, they share the same address space. Okay. This means any variable or any object in the memory can be accessed by all threads. Hence, the need for synchronization tools like mutex is highly required. Coming to the thread. So I could say that the process, you have a thread. Yes. So I am just representing the process as an independent unit, which means it has its own memory and resources. A thread is the execution unit inside a process. This yellow path, we can just say it as a thread. It's inside the process. And it shares the resources, but it has its own execution state, stack or program counter. It has its own execution state. It's given by stack on the program counter. And the wavy line here, it shows the flow of execution or the instruction stream of that particular thread. And here a thread is also called as a lightweight process because it's a sequence of instructions that the CPU executes independently, but within the context of a process. A thread is a lightweight unit of execution in one line, I could say, that runs within the process. Yes? Threads share the same memory and resources of their parent process, allowing efficient communication between them. Each thread can perform a task concurrently with the other threads in the same process, enabling parallelism and faster execution. And it's identified by thread ID. We call process by process ID, PID, and we call thread by thread ID, TID, commonly uploaded as TID. Thread IDs are process local. Yes, within the process. A thread has some attributes also, that is priority, scheduling algorithms, register set, CPU mask for multi-core, and signal mask. When you have 3 threads, you need signal masking sometimes. So all these attributes have to do with running. So detailed of this multi-core and masking will be seen later. Coming to process and threads put together, I could say that this in single line, I could say threads run code and process own resources. That's a key point of the entire slide. So I could say that is the entire thing process. It owns the resources, and thread, they run the code. Let's take an example. Open a web browser, and it's like a process. So the process owns memory, open tabs, and network connections. Threads inside it handle different tasks. Like one thread will render the page, the other thread will download the file, and the other listens for user input. So they all share the same memory and the browser data, but each runs different parts of the program, right? So this is what a process and a thread. As an example, when you open a web browser. And why do you need a process? Because you to provide isolation between the programs. You need to go with multitasking to allocate resource very safely to manage the execution and scheduling. Similarly, threads, I told you it run in a process. The process must have at least one thread, You can have n number of thread, multi-thread, but minimum one thread is required for a process to run, process to live. Threads in a process share all the process resources. So as I said, threads run code and process own resources. They are the keywords to understand and remember. Process or the building blocks, components of a system which are visible to each other, whereas threads or implementation detail and you're hidden inside the process, right? A comparison and or what's process and thread is being discussed in this slide. When you wanted to take it as just a small comparison, I could say that it's a program in execution, but here when coming to thread is the smallest unit of execution within the process. It is memory, it is PID, it is having its own memory space. Process, it has own its memory space, whereas thread shares the same memory space as the other threads. Process, they are hard to share data across the processes. It's easy to share here. They share variables and heaps. And it's slow. It requires memory allocation. Process requires memory allocation, whereas thread is lightweight creation. It's fast. And the quantum of context switching, it's expensive here, whereas in thread it's cheaper. And the crash is impact, the crash affects only that particular process. The crash can affect all threads of that particular process. Okay. Isolation, here it's a strong isolation. Here we have weak isolation between the threads, but you have strong isolation between the process. The scheduling is done by OS. Here the thread also by OS, but it is a lighter weight. So hope you understood process, threads, all in concepts of OS. Thank you.